Alright, good afternoon, Algebra 2 Trick Honors students. So today we would like to talk about Chapter 10, Probability. So for this chapter, it's good to know, it's not going to be tested as one of the chapter, but I think that it's something that you need to know for the SBAC, and also for the college entrance test, and also for the SAT 1. There's some of the basic problem there for the probability. So probabilities, so let's talk about the definition first. So what is that about? It's the measure of how likely something will occur, like the event, and it's the ratios of desired outcomes to a total outcome. So the probability, just like finding the percentage or fractions, is the number of desired over the number of total. So probabilities must be simplified if that's possible. Okay, so if that's a fractions, always you want to reduce, simplify it, right? Okay, so now let's look at that, the example. So let's say that you want to flip a coin. So what's the probability you get heads? And what's the probability you can get tail? So a lot of people might be saying that 50%, half, right? So remember, think of all possibility, all the possible outcomes, okay? So let's say that we do have a tree diagram. So let's say we do have two 6-size dice. I wrote it. And describe the sample space. So the sample space is not the number of the possible outcomes. So let's say that for the first die, you can roll 1 or 2 or 3 or 4 or 5 and then or 6. And then the second die, same kind of possibility. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. If you just multiplied it out, so 6 times 6, the total possible outcome would be what? 36 outcomes. So for the tree diagram. And also you can set it up as like a mapping diagram here. So two dies are wrote and the sum is noted. So 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. Or 1, 1, 1, 2 column, 1, 3, 1, 4, 1, 5, 1, 6, so on and so forth. If you count them all, it's 36 outcome. So find the probability that the sum is 4. So the probability the sum is 4. So you just count this diagonal here. So 3 plus 1, 2 plus 2, 1 plus 3. So we do have 3 out of what? 36 total outcome. So once you reduce it, it's 1 over 12. So for the decimal is 0.083. Convert that to percentage, then that'll be considered 8.3%. So find the probability that the sum is 11. So we only got 6 plus 5, 5 plus 6. So 2 out of 36. So 1 over 18, so 0.056. And find the probability that the sum is 4 or 11. So 4 or 11. So basically whatever those two probability that you have. So you just want to combine them together. So 3 over 36 plus 2 and 2 over 36. So it's 5 over 36. So it's 0.139. So basically combine 3 over 36 and 2 over 36. Okay, so now let's see what else that we have. And probability of success and failure. Definitions. So 1 success, desired outcome. 2 failure, any other outcome. 3, it's the random. And when all outcomes have an equal likely chances of occurring. And odd, another way to measure the chance of an event occurring. So this one is the ratios of the number of successes to the number of failures. Okay, so what I mean by this, so this one is just in general. So probability of success and failure. Okay, so now let's look at that. And what's the probability of rolling a die and getting the number 5? So the probability of rolling a die, so we only have 6 possible outcomes. So rolling a number 5, so it's only one chance, so it's 1 over 6. So 1 over 6, then that'd be the probability. And now, what are the odds? So the odd number, so success versus failure. So success versus failure, so the ratio would be considered 1 versus 5. Okay, so for the chances, well, because that's only one outcome, and then the rest of those chances, they're all failure. It's either getting what? 1, 2, 3, 4, or 6. So that means 1 chance of getting a number 5 and 5 chances of not getting a number 5. So success versus failure. So odds can be written as a fractions or ratio, but must be simplified just like probability. Success versus failure, so success over failure. So in sports, we often look at the wins over losses. Converting from probability to odds. So flip a coin 4 times. So you just flip the coin 4 times, so the probability of 2 tails, then that'd be 1 over 4. Well, the reason why it's 1 over 4, it's 1 over 2 times 1 over 2. Okay, so the first coin flip, so it's 1/2 of the, one chance to get the tail, and the other coin flip, so 1 over 2, the probability of getting the tail. So 1/2 times 1/2, 1/4. So it's about 0.25. What's exactly 0.25 or 25%? And what are the odds? So the odd would be what? 1 success over 3 failures. Okay, so 1 success over 1 failure, over 3 failures. Another way you can calculate this one, you can put in like 0.25 over 0.75. So 0.25, which is success, and the failure would be what? 0.75. So 0.25 over 0.75, then that'd be what? 1/3. Okay, so now let's see what else. And probability distribution, definition. And random variable. A random variable, so a variable whose value it's a numerical outcome of a random event. So for example, so when rolling a die, we can let the random variable D represents the number showing on the die. So D can be what? 1, 2, 3, 4, 5, or 6. And for number 2, probability distributions for a particular random variable, it's a function that maps the sample space to the probabilities of the outcome in the sample space. So this way, just read through the definition. Is kind of, well, the way that I explain it is kind of broad. Okay, so let's look at that example. So let's say that we roll a die. So the probability of getting 1, it's 1 over 6. Probability of getting 2, it's also 1 over 6. Getting 3, it's also 1 over 6. Whatever the phase that you're getting, it's just considered 1 over 6. And uniform distribution, a distribution where all of the probability are the same. So this one is called a uniform distribution because it doesn't matter which side I get. It's always the same equal chance. And then number 4, relative frequency histogram. So a table of probability or graph that helps to visualize probability distribution. But so far, no need to worry about this yet. Okay. And also probability, we do have 2 different type of probability. One is called the experimental, and the other one is called the theoretical. So an experimental probability, it's one that happens as the result of an experiment. Okay, so it's always the number of outcome over the number of trials. And the probability we have done so far has been theoretical because that there is no experiment. Okay, so there's no experiment, so it's always considered theoretical. Okay, so the probability of an event, it's a number between 0 and 1. So that indicates the likelihood that events will occur. So if there's no chance happens, so the probability would be 0. So 50%, half. Event that certainly occur, it's always what? 100%. So if that the probability of the event is 0, that means the event it's impossible. If the probability of the event it's 1, so that means surely it's going to happen. Okay, so this one shows you the inequality, the compound inequality for the impossible and for the 100% certain. Okay, so now let's see what else. And the theoretical and the experimental probability, so this one shows that chart. So the theoretical probability of the event, it's often simply called the probability of the event. So the number of outcome in A over the total number of outcome. So like the dot right here, the red dot over the overall dots right here. So 4 red dots, and then the number of total dot here would be 9. So 4 over 9. So we can express a probability as a fractions, a decimal, or a percent. So that's what we talked about earlier. An example theoretical, so number if way A can occur over the total number of outcomes. So it's always the same kind of formula, the possible outcome over the total outcome. So in the back, you have 3 red marbles, 2 blue marbles, and 7 yellow marbles. If you select one marble at random, so what's the probability of getting a red? So we do have 3 red marbles. And how many marbles do we have in the back right here? So total is what, 12? So it's 3 over 12. And which is what, 1 over 4. And here's the one for the experimental example. So apprentice went fishing at a pond that contains 3 types of fish. The blue gill, the red gills, and the crappies. He caught 40 fish and record that type. So the following frequency distribution shows the result. Okay, so 13, 17, 10. So the number of total fish is what? 40. And if you catch a fish, what's the probability? That's a blue gill. And a red gill, a crappie. Okay, so basically just put it into the possible outcome over the total outcome right here. So here's what we got. So in order to get a bluegills, then that'd be what, 13 over 40. And then red gill, then that'd be 17 over 40. A crappie, then that'll be what, 10 over 40, 1/4. And subjective probability results from educated guesses, intuition, and estimates. So examples, a doctor predictions so that a patient has a 90% chance of fully recovery. A business analyst predicting an employee strike being 0.25, so 0.5% of chance to have a strike. So anything that's considered predictions, educated guesses, intuitions, estimates, so it's always considered subjective probability. Okay, so, and for the independent, dependent then, we'll talk about that for the next sections. Okay, so thank you for watching the video today. I'll see you guys next time.